Greetings, everyone. Okay, so here are the solutions to practice exam number 2. And so the question for number 1 is we have these the region R enclosed by these two functions, natural log of the quantity x squared plus 1 and the cosine of x. And I believe they give you a picture with that, but in my version they don't. But even if they don't, it's a calculator question, so you could go graph it yourself. You need to find the area of R. Okay, so um, the red graph is the natural log graph, the black is cosine. This is the region here, and so if we were to sketch this out, it's top minus bottom, so it's gonna be cosine minus the natural log function. We do need the points of intersection for the two curves, and then you could use calculator for that one. I already did the work to get a couple values for that, and so for part A, the area here is the integral from negative 0.916 to 0.916. Top function minus the bottom function. And then just going to run that through a calculator. Since the calculator is active on this one, then you don't try to work this out by hand. You just want to actually run this through a calculator, which is, I don't remember, but I'll go look. So it's either 1.167 or 1.168, depending on if you round or truncate. Remember, they accept either, so both of those are considered correct, but anything different than either of those will not get the full credit. I think this is a 3-point question. I think it was 1 point, maybe a 2-point question, 1 point for the integrand, 1 point for the answer. Maybe 3, 1 point for the limits of integration included. I'm not so sure about that, though, off the top of my head. Email me if you want to know that. For part B, this is write an expression involving one or more integrals that gives the length of the boundary of the region R. Do not evaluate. This is a BC question, and some of us got it wrong. So if we're looking for the length of the boundary, we're looking for the arc length here all the way around. So I want all of this here plus all of this here. So I should write this as two separate integrals to work this out. And so the first integral, call arc lengths, will be from negative 0.916 to 0.916. And of course, this is an approximation because those numbers are rounded. Now, if I'm just talking about the cosine part, our integrand for arc length is the square root of 1 plus f prime squared. So I need the derivative of the curve. I'm doing this in terms of x. So since the curve is cosine, the derivative of cosine is negative sine, so I can put negative sine. Now, since we're squaring it, if you just put sine in there, that's fine too. This was like, I believe the first question was only 2 points because this was 4. We're not quite done yet, but you get 1 point for each derivative of each function, so that's 2, and then 1 point for each integral that goes with it. And so the next integral, same limits of integration, same structure, 1 plus something squared with respect to x. Note it said also do not evaluate, so I don't need to work out, I don't need to type this into my calculator or anything. I just need to write this down correctly. Now I'm going to take the derivative of the natural log of x squared. So derivative of natural log is going to be 1 over the input, 1 over x squared plus 1 times the derivative of the input, which is 2x. So I'll put the 2x in the numerator. So that was a 4-point question right there. And then lastly, for part C, I still don't remember if the first one was 2 or not, but this is the base of a solid is the region R. Each cross-section of the solid perpendicular to the x-axis is an equilateral triangle. Write an expression involving one or more integrals that gives the volume of the solid. Do not evaluate. Like those do not evaluates. Just saves us time. So if I look at this length right here, top minus bottom, this cosine of x minus natural log of x squared, just like we used for part A, that is the side length of the equilateral triangle. And if you remember the formula for an equilateral triangle, given its side length, if its side length is s, then the formula for the area is going to be root 3 over 4 times s squared. If you don't remember that, then go look that up in your notes, because I gave that to you. We derived where that came from. So to find the volume, we just got to integrate the area of the cross section. So same limits of integration. And the root 3 over 4 can go out here, or it can go on the inside. It does not matter. It's the same thing. We got to square that side length. So cosine of x minus natural log of the quantity x squared plus 1, all with respect to x. That's 9 points total. I remember B was 4, so either A was 2 and C was 3, or vice versa. Either way, wasn't that hard of a question. We should have done really well on it. Some of us did. A lot of us forgot the arc length integral, so take this as a good time to go back and remind yourself of it. So for question number 2, it says the function g has derivatives of all orders, meaning you can keep taking derivatives over and over and over again forever. And the Maclaurin series for g is this. Now I told you guys that even if you hadn't watch the video for the Maclaurin series or for 8.7 to know what a Maclaurin series is, I told you ahead of time that a Maclaurin series is a power series. And so all you need to know is that it's a power series to be able to work out all the answers to this question. Now for part A, it says using the ratio test, determine the interval of convergence for the Maclaurin series for G. This is a heavy question. I think this might have been 5 points. It was at least 4, but it might have been 5. So there's a lot to do in this question. So we're going to set up the ratio test. So we should know that the ratio test is the limit as it approaches infinity of the n plus first term. So this is going to be x to the 2 times the quantity n plus 1 plus 1. Some of you messed that part up right there. So if that was you, let's try not to do that mistake again. Same thing similarly down here, 2 times the quantity n plus 1. You can jump right into multiplying by the reciprocal of the original expression. They will be okay with this. Okay. Now notice I didn't put the -1 to the n in here because -1 to the n is going to be irrelevant with the absolute value. It's okay if you leave that out. That's not part of the solution, a necessary part of the solutions. So you get 1 point for just setting this up correctly. You get that far, you get a point. I mean, some of you just abandoned ship and didn't do anything. You should know the ratio test. You should be able to set that up. A sub n plus 1 over A sub n, absolute value, limit. You set that up right, you get a point automatically. Now the rest of this is just, a bunch of different algebra, simplifying arithmetic algebra. Let's simplify the exponent here. So this is going to be, if I distribute the 2, I get 2n plus 2 plus 1, so 2n plus 3. Down here, we're going to end up with 2n plus 5. I got 2n plus 3 here, and I got x to the 2n plus 1 here. So some of you made some mistakes in simplifying, so don't do that. Obviously not. But if I cancel this, these two are going to cancel a bit. What do I have to? I have to subtract the exponents because I'm dividing. Same base, subtract this was 2n plus 3 minus the quantity 2n plus 1. The two n's are going to cancel, and I'm going to be left with 3 minus 1, which is 2, so I'm left with an x squared up here. Now, in this direction over here, none of this stuff can cancel because of the addition that's happening, the plus 5 down here and the plus 3. All of that has to go along for the ride, so to speak. So that some of you canceled some stuff there that you shouldn't have, that does not cancel. And so let's see, what do we have left? We have x squared times 2n plus 3, all divided by 2n plus 5, because this became a 1 right here after we did the canceling. Notice I still have absolute value in here because although n is positive, so the quantity 2n plus 3 and the quantity 2n plus 5, those are positive. N, because n is going to infinity and starts off at 1, x squared still could have negative quantities for x. So I want to keep the absolute value in there. Now x squared is non-negative. Keep it in there, okay? Well, what happens to this ratio as n goes to infinity? Well, they have the same highest power. They're both to the first power. And so they're going to just go to the ratio of the coefficients of that power. 2 over 2 is 1. So all of the stuff in green as n goes to infinity is going to become 1. And what are we going to be left with? The absolute value of x squared, which is just x squared because x squared is already non-negative to begin with. But I want you to keep it in there that long because it doesn't always work out like this. Oftentimes, it's not to an even power, so the absolute value will have more effect. Now, once we get this far, that's another point. Okay, now we're going to use the ratio test. The ratio test says that if this value is less than 1, then the series converges. So I let this be less than 1. When is x squared less than 1? Well, that's when x is between -1 and 1. So that's my interval so far. As they call it in the solution, that's the internal interval, okay? Meaning I have to identify that. So that's your third point. 1 point for set up the ratio test, 1 point for getting the limit, 1 point for looking at the internal values. The next point comes from testing the endpoints, okay? Because remember, the limit test, so the ratio test fails when x squared is equal to 1. So it fails at -1 and it fails at +1. So I have to look at those separately. So if x is equal to -1, I got to go back to my original series, which looks like this, -1 to the n. Let's see, I don't remember it now. X, so -1 to the 2n plus 1 over 2n plus 3. And if I simplify this, well, what happens here? So let's make sure I copied everything correctly. Okay. So this thing up here, this is always an odd number, which means that this is always negative. And this one over here is sometimes negative and sometimes positive. Okay. So when n equals 0, this is going to be positive times a negative. So we get a negative. When n equals 1, this is going to be a negative times a negative, which is going to be positive. Okay. When n equals 2, we're going to get a positive times a negative, which is going to be negative. So it looks like we're always going to end up with -1 over 2n plus 3. I said when n equals 0, we need a negative. When n equals 1, we need a positive. So it looks like it comes out to be this. So when I plug in 0, I get -1 to the first power, which means negative. Like I said, we're going to get negative. When I plug in 1, I get -1 to an even power, which means positive. Like I said, when n is 1, we'll get a positive, and so forth. Now, some of you just said, oh, it's alternating, so it converges. That's wrong. You have to actually show some work here. Okay, so this is alternating. I should say this is incomplete if you say that. And you should use the alternating series test. Okay, this is alternating. So as we do, the limit as n approaches infinity of 1 over 2n plus 3 is equal to 0. And let's see, 2n is equal to 2n. You could take a derivative, by the way. You could just set f equal to this, take the derivative, show that it's negative, so it's decreasing. But if I do this, this is true. This is true. And so, whoops, that should be a 5 right there. This is a sub n. This is a sub n plus 1. And then all of this tells me, because this tells me decreasing to 0. So by the alternating series test, the series converges. And then we got to do that when x equals 1. So if x equals 1, then we're going to get the sum from n equals 0 to infinity, -1 to the n. We have 1 to the 2n plus 1, 2n plus 3. Now this one here, we don't have to show as much work. This is now -1 to the n over 2n plus 3. So this is the same alternating series with, except for the signs are opposite, okay? So you could even, if you wanted to, you could, I just put it in words. So, which is the opposite of the series when x equals -1. So it converges as well. It's a lot of work for the fourth point. And then the interval of convergence is the closed interval -1, 1. Just write that in a sentence. That's the fifth point. Okay. I know it's a lot, but that's, you know, that's what they're looking for. I'm going to move on to part B. It says the Maclaurin series for G evaluated x equals 1/2 is an alternating series whose terms decrease in absolute value to 0. That tells you that the series converges. The approximation for G of 1/2 using the first two non-zero terms for the series is 17 divided by 120. Show that this approximation differs from G of 1/2 by less than 1 over 200. This is an alternating series. So G of 1/2 is equal to the sum from n equals 0 to infinity, -1 to the n. Oh, I don't remember the series that well. It's x to the, okay. So it's 1/2 to the, I thought there was a subtraction happening there, I've forgotten. So 2n plus 3 like this, okay? So what we're trying to do, we're trying to bound the error in the second partial sum. That's what they're saying, that using the first two terms, that differs from the actual value by less than 1 over 200, okay? Or, I'm sorry, I might be wording that wrong. We need to show that it differs by less than 200, okay? Well, we know that this is going to be less than the error in less than or equal to the error in, less than or equal to the third term, the next term not included in the series. So let me actually insert one thing. This is just the R sub 3. That's what this is, okay? No, it's not. It's R sub 2, which is less than or equal to A sub 3. So what is A sub 3? Okay, A sub 3 is 1/2 to the 2 times 3 plus 1 over 2 times 3 plus 3. What's that? 6, 7, 1/2 to the 7th over, that's 6 and 3 is 9. I'm pausing for a moment because it looks like my arithmetic might be a little bit off somewhere. But hey, if I made a mistake, I'll fix it later. 2 to the 7th is, what's that? 128. Yeah, because 2 to the 6th is 64. So 2 to the 7th is 128 divided by 9. I think my numbers are off for a moment. I need to go double check if where my arithmetic went bad. So I'm going to pause and go look for it. All right, it's not my arithmetic that went bad, it's my ability to count that went bad. We're starting at 0. And so this is, the first two terms come from 0 and 1, even though this is the third term. I have to pay attention. This should be plugging in a 2. Whoops. Change this here. And this is plugging in a 2 down here. So this becomes a 5 and a 7. So this is 32, and this is 7, and then that's 210 and 14 make 224, and 1 over 224 is less than 1 over 200. So lesson learned, ladies and gentlemen. Pay attention to where the index starts. I wasn't, and moving way too quickly, or trying to move way too quickly, managed to mess it up there. That wasn't very many points. I think that was 2 points, one for using the third term and one for showing it's less than 1 over 200. And then last but not least, sorry, I was looking at the wrong thing. Write the first three non-zero terms and the general term from the Maclaurin series for G prime of X. All right, so for part C, they told us that G of X is equal to X over 3 minus X cubed over 5 plus X to the 5 over 7. I hope I'm getting that correct. I should go back up and just copy it down. Yeah, and then negative 1 to the n. Okay. Plus dot dot dot. Actually, it should be a minus dot 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 plus negative 1 to the n, x to the 2n plus 1 over 2n plus 3. I think this is a 2-point question. Yeah, B was a 2-point question and C was a 2-point question. So G prime, just take derivatives term by term. Derivative of x over 3 is 1/3. The derivative of x cubed over 5 is going to be 3x squared over 5. And then plus 5x to the 4th over 7. That's 1 point. And then there's 1 point for the general term. Negative 1 to the n, you're going to leave that alone. You're going to bring the 2n plus 1 down. You're going to subtract 1 from the exponent and then leave the denominator alone, plus dot dot dot. And that's it. It's really that easy for that question. A lot of you made it harder than it actually is. All right, question 3, we got a differential equation question. They give us the diffie-q, they give us even the second derivative. Y equals f of x is a particular solution to that diffie-q with f of 1 equals to 2. We want to write the equation of a tangent line. So that should be pretty straightforward. It's the equation of a tangent line at x equals 1. So what do I need to know? I need to know the slope at x equals 1. Okay. Now notice we know when x equals 1, y is equal to 2. And so we're going to use that here. In fact, it might be even better for you if you put it as a ordered pair 1, 2. So plug in 1, plug in 2, and then you're going to get 8. And so then the equation of the tangent line is going to be 8 times x minus 1 plus 2. I think that's a 2-point question. Excuse me, my nose is acting up. But you probably noticed it. I think it's 1 point for the slope and 1 point for the equation. For B, use the tangent line equation from part A to approximate f of 1.1. Given that f is positive on this interval, is the approximation greater than or less than the actual value? Explain your reasoning. And so 1.1. So f of 1.1 is going to be approximately y of 1.1, which is 8 times 1.1 plus 2, which works out to be 2.8. And to do this, we need to figure out the second derivative, if that is positive or negative around 1, 2. And so y cubed, that's 2 cubed times 1 plus 3x squared y squared. Well, I got values for those. 1 squared, 2 squared, and then that's positive. And so then you say something like, since the second derivative is positive, the tangent line lies below the curve, so this is an underestimate. Something equivalent to that. I think that's a 2-point question, but it might be 3. I didn't hold all these point values in my head. Lastly, part C, find the particular solution. I think, yeah, it's 2, 2, and 5, I think. I think C is 5 for this one. And so we're solving the diffie-q. So we know dy over dx is equal to whatever it said it was, xy cubed. So we have to separate the variables. That's a point, just separating the variables. And you get nothing if you don't use separable diffie-q's. You find an antiderivative, so it's going to be negative 1 over 2 y squared equal to half x squared plus c. A point total for the antiderivatives and a point for c. So up to this point, if you've done this much correctly, you got 3 points. The next point is using the fact that f of 1 is 2 to generate the value of c. And so it's 1 over 2 times 2 squared, but that should be negative, is equal to 1/2 times 1 squared plus c. So this is negative 1/8 is equal to 1/2 plus c. I'm going to go back up here now. So c is equal to negative 1/8 minus 1/2, which is negative 5/8. So that's the fourth point. And the fifth point is actually solving for y. So negative 1 over 2y squared is equal to half x squared minus 5/8. And so I would multiply by negative 2 first to get 1 over y squared. And this becomes negative x squared plus 5/4. Take reciprocals. Now, when you take reciprocals on this side, you got to take reciprocal of the whole thing. Some of you like to take it of individual terms, and that's mathematically very bad. And then we've got to take a square root. Now, we could get a plus or minus, and we should make sure that we choose the correct one. Okay. Now, since we want f of 1 equal to positive 2, which is greater than 0 here, so we want the positive one. So the final answer is going to be the square root of 1 over negative x squared, all this stuff here. Five points for that. And that's it. Go study. Learn from your mistakes, ladies and gentlemen.